So in the previous video, we talked about how you can specify preconditions to make sure it's actually the proper surface condition. And then we see how we can actually cause some violation as expected to test for illegal input values. And for that, we need to specify violation tests using commands rather than Boolean test queries. So that's something you would like to get clear before you watch the current video. Okay, we're going to do something similar. So the other part of the contract or specification for the make command will be the post condition. After the implementation has been executed, what would be the obligation for the supplier to actually fulfill? That's something we'd like to specify. And for the make command, it's actually quite a simple one because we know that conceptually, we just want to set the month and day to be N and D respectively. So the post condition should just be about these two attributes. So we can do something very straightforward. Let me just do it together with you. So the syntax would be so this will mark the end of the implementation. So now we start to specify the post condition. And now we want to say for each post condition, similar to invariance and precondition, you may want to give a tag. So later on, you can trace it more easily in the debugger, right? As we illustrated before. So now, first of all, let's say the month has been set. So let's say month has been set. So that'll be one tag. So that simply means the value for the month right now, which is the attributes, should be equal to, and equality is a single equal. So you want to make sure you use single equal for equality and call it equal for assignments. It's equal to M, and also the day is also set to be day is equal to D over here. Okay, so now if I simply try to compile over here, everything compiles. And then because the implementation is quite straightforward, right? It's really hard to get wrong. But I want to use this as a simple example to show you it's not necessarily the case that the supplier will always do the right thing. You will hope they will do the right thing. But if they don't, you really want to trigger some post-condition violation to blame them, basically, right? That's the obligation for the supplier. I wanted to use this simple example to show you. At the moment, this particular implementation is simply just correct. So let me just emphasize that, right? This is correct implementation. Because it is correct implementation, so remember there was a test case on this. Let me just go there. If you go to test birthday, this is the test Boolean query that we did previously to create a valid birthday, right? That's what we did previously. That one there, we actually tried different combination over here. And then we actually saw all of them actually pass, okay? So now, let me simply just go back here to birthday, and then let me just run, and then run workbench system. So it's a green bar, so everything just works, which means the precondition is either satisfied or is violated as expected, right? So for example, in this particular case that we did in the previous tutorial video, the precondition was triggered to be violated as expected. So that's why it should be part of the green bar, okay? And then for this case, for example, over here, the precondition is just satisfied. So that means it's valid inputs. And then we execute the implementation, and then the post states also satisfy the post condition. So this one here is also considered as a pass. So now what we want to do is, we want to think about some scenario over here. How do we know the post condition will really be triggered to be violated if the implementation was wrong? What I meant by this, let me illustrate something not ideal for you, right? Just imagine that later on you may want to program command or query whose post condition might be much more complicated than this. We might do a slightly more complicated example in the later in the tutorial series if time permitted. Otherwise, you will see later in the class we do have some much more sophisticated post condition. But let's just focus on this one here. So now let's say here, if the post condition is actually good, so that means any faulty implementation is going to trigger some post condition violation. For example, let's say I want to see if the day set over here is really the one is really a correct one, which means it's going to be triggered when necessary. Okay, so now I'm just going to, for example, I'm going to say day is assigned to. Let me say it's a ROM implementation now, just for now. I'm just going to change that temporarily. ROM implementation, and then day is assigned to also M. Okay, and then everything will still compile. So now what I'm getting is I got some very good post condition over here, which is going to help me actually catch the error. However, the implementation here is actually wrong. So what I expect to see is if I try to say run workbench system, the test should fail. Okay, otherwise the test is not good enough. So now if I say run workbench system, that's good, and I do have something called post condition violated. Okay, to be more precise, we want to see the stack trace. Why don't we go to the debugger? So if I say run over here, I'm going to see exactly how that post condition is violated. So you can see the stack trace. When we actually call the t create new birthday here, and as soon as we try to create the first one, October 15th, right? And for that one there, so if I go to the make, so think about it's October 15th. So this will be 10 and this will be 15, right? So that means the day is also assigned to be 10. So it becomes October 10th, right? So you can see this is actually, this ended up to be the result, October 10th, rather than October 15th, that's expected. So that's why you violated this particular post condition, right? Because the month is still October, that's okay. However, the day is actually 10th rather than 15th. So that's the problem. So the post condition over here is actually good. Okay, it's actually very good. However, as we said before, in this particular case, because the implementation is actually wrong, right? In that case, having a post condition violation in response to a faulty implementation should not be considered as a bad response, or more precisely, it should not be considered as a failure of the test. It's pretty much like if the precondition is simply violated because of invalid input, it should be considered as a good response. That's something we were trying to explain to you in the previous video. For this video, we're going to do something similar. Okay. However, in order to test the post condition, it's going to be trickier to test it. The main challenge is we really want to, well, because you simply just don't want to modify your correct implementation in the code over here, because what if you forgot to change back, then you'll be in trouble. So let me say, you pretty much see, pretty much see what the issue is, right? If we want to make sure with a wrong implementation, we will be able to trigger, for example, this particular post condition. Okay, let me just mention one more thing to you. Okay, you can see here we got this particular post condition here. Also, we got this post condition here. At the runtime, for post condition here, it's going to be checked one at a time. We will only get to check this particular post condition if all the previous ones are already satisfied. Otherwise, the earliest one that's violated will interrupt the flow. Okay, similarly for precondition, right? So for example, if you already violates the valid month, then you wouldn't get a chance to even check these two because that's the earliest one to be violated. Similarly, let's say the month is valid, but the day is not valid. In that case, you would actually get interrupted from here. You wouldn't even get a chance to do valid combination, right? So basically, contracts are checked sequentially. Okay, that's something I want to mention. But you may have picked up, you may have already picked up already. Okay, so how do we do it? Let me show you the solution, and then I'll explain to you why the solution works. Okay, it's gonna involve some use of inheritance, polymorphism, and dynamic binding, specifically dynamic binding. So let me change it back to correct implementation over here. Okay, so now I still want a green bar there, but now I'm gonna show you how you can create just another. Oh, let me compile. Always remember to compile for your change to take effects. And then I'll simply say run workbench systems. Now everything's compiling. Okay, good. So now I'm going to create a new violation test case, just like the precondition, but the setup is going to be different. The tricky thing is I want to create some alternative universe, alternative implementation that's actually wrong without affecting this particular make over here, because the make is going to be delivered to the customer, so they shouldn't be touched. I just want to create some testing version to make sure with that testing version of the wrong implementation, I can successfully trigger this particular post condition to be violated. Okay, let's see how to do it. The way to do it is by creating a new class. Okay, so now to make it more systematic, I would suggest, first of all, go to your desktop and then remember that particular project for the birthday book, right? Go into it And now I would say go into tests over here. Okay, so now I want to create a new folder over here, which will be identified as a cluster. So what should be the name? It can be any name. So how about here I just say Postcondition. So whatever class I'm going to create over here is going to be for the purpose of Postcondition tests. Okay, so initially just empty. Okay, and then go back to iPhone Studio, and then I'm going to say compile. You can see there's a Postcondition cluster that is actually empty for now. Okay, click on the Postcondition cluster here, and then add a new class. So let's say I want to create an alternative version of the make feature, basically, but I'm going to create a class first of all. So let me just say bad birthday. Okay, you have to work on the naming a little bit. How about this? I'd say bad birthday violating day set. Okay, so I'm trying to be as informative as possible. I'm creating a bad version over here. I'm creating a bad version of the birthday class. And why is it bad? Because it is going to violate the day set postcondition, like a postcondition with a tag. So create this particular one, and then how do I create inheritance? Okay, let's write it out. So this will be the first time you're going to use some inheritance in iPhone, but the idea is similar, except that in iPhone we do have multiple inheritance sometimes that you may want to use. But for this particular one, we don't have to use multiple inheritance. Okay, we'll say inherits. I want to inherit from, okay, let me also get birthday into the context over here. I want to inherit from this particular birthday here. Okay, I would say inherits. Whatever class you want to test, you want to inherit from there. Okay, and now, which feature specifically do I want to test for its postcondition violation? It is the make command over here that I want to test. Okay, so I will go back here, and then I'm gonna say, okay, so I want to somehow to create this alternative version of the implementation for make. So I'm gonna redefine. Think about redefine as like override. So you have to explicitly say you're going to redefine this particular feature or command. So I'm gonna say redefine, and then redefine over here. You can specify as many features as you like that's gonna be redefined, separated by comma. But for this one, just one, just make. So I'll put the make over here, and then put n over here. Okay, and then for this particular class, what should be the constructor? So I would say let's just leave the same constructor as the birthday, right? So you have to redeclare this particular constructor to say make being the command should also be used can also be used as a constructor. So now let me go back here. So I would say creates make. Okay, so now let's start the bookmarking. So you should really get at least one feature bookmark. So in this case, just feature. So the only, okay, let's say redefine command. Okay, the only command that we want to redefine is the make. For the rest, we simply just inherit them from the birthday class. Okay, so what do we do? So it's still going to, okay, let me just show you the process. You may just want to copy and paste the header over here. Okay, just copy that, and then go back here, copy and paste. Okay, let's not worry about the comment. It's gonna be the same feature. Okay, do and end. Okay, so here we're going to supply some ROM implementation. Okay, so let's say month. Oh, because let me just mention one more thing. Because we actually want to trigger the violation of, let's say, day set. Let's say that's the post condition we want to test. In order to test that, you want to make sure the month set is actually satisfied. Because otherwise, if the month set, which happens earlier, is already violated, you don't even get a chance to check for this, right? So that's why I chose this one to test for you. So you want to make sure you give the wrong implementation just enough to make sure it satisfies this particular one here, but it fails the day set here. Let me go back here, and then I would say month. So this will be correct. However, I would say day is also assigned to m. So that's wrong. Okay. So this line should trigger a postcondition violation with tag. So that should be day set. Okay. So now, what should be the post condition? The idea would be you don't really declare any post condition here. It is something called subcontracting, which we will talk about later in the course. Conceptually, it goes like this, just for now. As far as now is concerned, you can understand this way. The precondition and the postcondition from the parent class, in this case birthday, will be inherited verbatim to the subclass. In this case, the bad birthday violating day set. Okay, that's the contract is going to be inherited. That's why things will work to test the postcondition violation in this case. Okay, let me just mention here. Do not write any postcondition here. All the postcondition from birthday will be inherited. So there's no need. Okay, so let's make sure it compiles over here. Okay, so everything compiled. And now I'm done with the setup. So think about for every post condition that you would like to test, you have to create a corresponding class. Okay, so I would say this is a little bit more advanced, but I do want to mention this in the introductory tutorial because for your lab number 1, you will be asked to write many post conditions. So for your convenience, you may want to test for the post condition. Okay, that's why I want to mention here. Okay, so now we got this new class over here. We're going to use it in just a moment. So let me go back to test birthday over here. So now I'm going to go to the violation tests section here. And then let me just continue from our precondition test. Okay, so let's have a consistent name for the violation test. Let's say T underscore postcon and then birthday make. And as usual, we're going to manipulate some local variable. But now, rather than having the type being birthday, you can think about the birthday class contains the correct implementation for the make. But we actually want to call the wrong version of the implementation for the make, which is store in the new class that we created. Let me remind you, which is this in bad birthday violating day set, right? We want to call this version over here. In order to do that, the easiest way is, why don't we declare a variable of this type? Okay, let me go back to the test over here. So here I would say local BD over here. So now it's going to be bad birthday violating day set and then do n. Okay, so now don't forget, you always should put a comments here for the test. Okay, comments. Okay, let me just copy and paste this particular command name over here and then test that the post condition. Okay, let me maximize it. Oops. Okay, the post condition with tag day set is violated as expected, especially is triggered by some wrong implementation that's defined in this particular class over here. Okay, and what should we do? Okay, well, we simply just call the make as a constructor when it creates the birthday objects. So create bd.make. And let's use the example that we said before. So October 15th. Let's say that's the day, month and day we would like to create. So now the ROM implementation in. Okay, let me just copy this one just for documentation. Okay, so now I want to put in the backroads so it appears a little bit in different color. Okay, so the ROM implementation in bad birthday violating day set should trigger the post condition. Okay, let me just should trigger the post condition with the tag day set. Okay, so that's really the idea. So we're expecting that when calling this particular make as a constructor, the precondition will be satisfied. Okay, October 14th is actually a valid combination, valid month and valid day. And then it's going to execute a wrong implementation, which is specified over here. month is going to be assigned, okay, it's going to be October 10 and 15, right? Month will be 10 correctly, but day will be also 10 wrongly. And then this particular make feature here inherits the post condition from its parent class, which is going to check to see if the month is set. In this case, yes, month has been set to 10. However, the day has been mistakenly set to also 10, but rather than 15. Okay, hopefully you can follow the story here. Okay, so now make sure everything compiles, but to make sure it's actually included in the test execution, we will have to include it. It's a violation test case, right? So now let's go back to the make for the test birthday as we did before. So add underscore violation case with tag. So now the tag should be day set, right? And then we have to give the pointer to function for that particular command for the test. Agents t underscore control space and then post condition. Okay, so now I use code completion here. So now I'll just compile everything. Compile. So now before I run the workbench system, I want to first make sure that this post condition really is going to occur. If I say run, am I going to see this post condition violation first, or there's something else that will happen earlier? Well, the answer is this particular precondition violation test, which we did in the previous tutorial video, that one there, if I say run, is going to happen first because it is arranged first. It actually goes before this particular test, right? So now we're going to see that precondition violation first, and then we're going to, if you want to see the postcondition violation, then we have to say run again. Okay, I'll show you. I just want to tell you that you shouldn't be too surprised that we see the precondition violation first. So I would say run over here, and then as expected, we actually see this particular stack trace, and then that one there, you can see by calling this particular violation test command that we did in the previous tutorial video, is going to trigger the precondition violation in the make, right? That's the first one. And now if we want to continue, we simply say run. And then now we do see the post condition violation they set over here, right? So that means by having this, okay, it's very important to actually see this, right? You can see now when we call, let's see, when we say test post condition command over here, because the type over here is actually bad birthday violating day set. So this is the static type. However, since I didn't put any curly brackets over here, so that means dynamically the object is also the same type, bad birthday violating day set. So that is why when I call this particular make here, so one little exercise for you, you can set a breakpoint over here and then launch it again. And then when you actually pause over here, you can step into it and see which version of the make it is calling. It must be the version from this particular class. Okay, that's something similar we did in the previous video. I'll leave you to exercise that yourself. Let me go back to the top of the stack. So now it is really this version that is wrong, the wrong implementation, and that one they trigger this particular post condition. Of course, you can see day is equal to D. So now you can see at the moment it's being set wrongly. You can see the day is actually 10 rather than what's intended, right? What's intended was 14 over here. If you look at this, oh, actually I put 14 rather than 15, but doesn't matter. You know, that's the expected outcome to actually have. So now it's actually 10 over here rather than the expected 14. So it's actually, of course, it should be a post condition violation. Okay, so now the expected post condition really occurred. However, are we going to get a red bar or green bar? Okay, because this is actually added as a violation case with tag. So as long as the violation that occur over here is actually a day set post condition violation, then we will be okay. So now if I say run over here and run workbench system, so everything still pass, right? As far as unit testing is concerned, you can see for these for this one here is testing for some expected precondition violation, and this one we just did is testing for some expected post condition violation. If you say run rather than run workbench system, you will see both the stack trace for both of them. However, if you say run workbench system, those violations will be treated as expected, and so that's why they are treated as passing. Okay, so please really make sure you understand the difference between run versus run workbench system. And also, there's a way called violation test command for you to say, I want to run this particular command or query over here, and I'm expecting certain violation to occur, either precondition or postcondition. That's really the focus for the previous video and this video. Finally, I would like to summarize by talking about the architecture of this particular setup. So for the postcondition, because we're adding one new class to the system, and also we're using inheritance, so it will be worth discussing this quickly. Okay, so these are the three critical classes that we're using. Let me explain one by one. For the test birthday class, for the unit testing class, it is actually in this case the clients or the user. How do we see that? So now if you go back here to the code to iPhone Studio, so now you can see that for this class of your test birthday is actually the client class, because in this particular feature here, right click to drag, right click to drop. Okay, you can see that this particular feature in the test birthday class is making use of some service from this class. Bad birthday violating date set, and BD is the name of the supplier, right? We talk about whenever you got variable declaration, that indicates you have a client-supplier relation. So now you can see the supplier name is actually BD, and it's actually pointing to the supplier type. And then this will be birthday violating date set specifically, right? And more importantly, the way we set up this particular new class is as follows. We say birthday violating date set class is actually inheriting from the birthday. So now we actually got two versions of the make, right? So now in the this little detail here, which will also be talked about later, I just want to mention it here to you. How do you indicate if a command, like a routine, is either implemented or has been overridden? Okay, so now if you only got a single plus, like annotation, that means it's we call effective or implemented. Okay, and then because that's already implemented, that's like a version 1 of the implementation. And now in the subclass over here, so you can see plus plus, that means it's being redefined. And the redefine corresponds to, remember, if we go back to that particular new class that we have created, you can see that's why we put redefine over here. It's like a plus plus. Okay. And then it's redefined, and then we actually simply got some wrong implementation by setting wrongly the date. You can think about this as version 2. So we actually got two versions of the make implementation, the correct version, version 1, the wrong version, version 2. Okay, but because the test themselves is the test itself is actually referring to the wrong version, so it's going to call this particular wrong version. At the same time, also very important is this is the post condition for the parent class. It will be inherited verbatim to this particular make redefined version. So it will be inherited. Okay, this is something called subcontracting, which we will talk about later in the course. Okay, so now for version, so we are basically executing version 2 of the wrong implementation, whereas we are being checked against the post condition over here. The first one will be satisfied, month, nothing wrong with setting the month, but we will get trouble when we actually check this particular post condition for setting the day. So that's why that one there is actually violated. Okay, that's basically the overall structure for what's happening over here. So try to study this example here, both at the code level and also at the architecture level. And something I forgot to mention. This arrow over here is client supplier. Usually, if color is allowed, we will actually use green to actually say client supplier. Whereas for this particular single line arrow that's red, that means inheritance. So this particular class inherits from its parents. Okay, study both the code version and also the architecture version for testing the post condition violation. And then before you move on to the next video, so far we talked about 3 kinds of test cases. Either you have a Boolean test query, or you can have a test command for precondition violation with a tag. Or you can also have a test command for testing the postcondition violation with a tag, in which case you have to create a new bad version like this over here for wrong implementation. So it's a very quick summary of all the 3 kinds of test cases you can do in order to achieve test-driven developments.